Welcome to a new test and teardown video. Yay, another Fluke. I don't know if I collect Flukes or something like that, but I kind of like Fluke is a good brand of super high quality stuff. This one is the 891A DC Differential Voltmeter. It was presented by Fluke in their catalog in 1967. So it is that old. I've been Googling a little bit around and we find quite a lot of different models. And they look a little bit like the same. For example, the 887A. And that one is on eBay for $1,700. That's quite nice. I also find an 893 for $150. And if you see the picture here, you can see at the bottom left, you can see the logo. So that means my unit here is missing a nice little logo sticker here, so that's a little bit annoying. I kind of like them to be nice and beautiful. I also found on eBay the 891 exactly like mine for only $130. They don't say if it works or if it's super good or anything like that, but so I'm just trying to say that this one isn't full of gold or anything like that. It's not super valuable. I found a calibration sticker. So my unit was last calibrated in 93 and next calibration was due 95. Isn't that nice when somebody put the calibration stickers and any other stickers on the side of the instrument? Yay! Beautiful! Finally! So I spent quite a long time washing this front. It was sort of balsamated in yellow goo, but now it is nice and beautiful. Yeah, I need to open this one and see exactly what is going on. But I just want to really fast tell a little bit about what this thing is doing here. So, of course, this is a voltmeter. But the cool thing is this is work as a bridge where you input a voltage. And this voltage is compared to your input voltage. And the difference is amplified to that meter. So we have some different sensitivity, and this says a little bit about how aggressive is the readout. And it also says a little bit about where are you here on the knobs when you want to dial in the voltage. Obviously you can't be in this super sensitive area and then dial in on the highest number here, right? So you need to move the sensitivity along with the knobs you're dialing in. Also, I think there are a few really sexy things with this unit. See the range, I am now in the 1 volt range. And here I can, of course, the lowest sensitivity is 0.1 volt for the differential, right? So this first digit here, you see 0.6, there's a little dot here. But it can go to 10. So that means 1.0. Okay, so that means 1.0. That was the 100 millivolts and 1 volt, right? So this is 10 millivolts, 1 millivolt, and then 2 digits after 1 millivolt. So, as you can see here, you can even read out the different digits down there, right? So if this is really true, today you need a 5.5 digit meter to beat the resolution. I'm not saying accuracy, but to beat the resolution. So what happens when I change the ranges? Here comes the cool thing. Can you see what happens? Of course the sensitivity moves, but also check out the dot down there is moving. And all this is done mechanically. Don't you just love it? That is so wonderful. And it runs rather smooth as well. I don't find any indicators whatsoever. Even the power switch, see? It's done like that. Mechanical indication. There isn't any little lamp or anything. So you don't know if it's really powered or anything. I tried to shake the unit a little bit this way, and the needle does indeed move. So I really feel that it's nicer and everything like that. But let's open and have a little visual inspection. The back of the unit reveals some little part is missing here. So it is this piece of aluminium that is normally glued or press fit into this piece of aluminium here, but that is missing. But I'm quite happy about it is the back one here that's missing, because otherwise it would have been visible and all that. I just checked the fuse. That looks nice and good. This connector is not a big problem for me anymore. I got this unit last weekend at a local flea market, and I was super lucky also to get the original cable that fit. So that is good as well. I don't have the battery pack option or the recorder output option installed. That would give us the extra BNC connectors here for the recorder output. Another thing that I noted, the handle here, this thing is rotating like that, and I had the idea that this was not normal, but all the pictures I could find, even really old pictures, also shows this thing rotated like that. So what really? What is the point? So, and the idea is obviously you just tighten those screws and that should hold the unit to a stable angle or something like that. This is not really working. You need to have this at an exact, perfect, straight balance point, and then you can tighten it. And it's still not, super good. They made it a little bit flat here, so you could probably figure this out, but yeah, well. The first visual inspection revealed nothing bad to worry about, so that's super good. Let's start at the most boring part, the bottom. So we got the 3 switches. The fun thing is the first one here is an 11 position switch, and this one got a stop, so you can't dial it all the way around. The next 2, that's just normal 10 positions, and you can just continue all the way. And the last is a high precision potentiometer with, of course, as you can hear, yeah, real nice and all that. Down here we got all the resistors for the different set points here. And well, I don't expect to pull it completely apart, but they are wire wound high precision resistors like that, quite big. Because to be able to pull these out, I don't want to break any of the wires or cause any kind of problems here. So you're not really supposed to get that shield off easily. So let's just imagine we got a lot of high precision resistors in here, and then we are quite happy, right? We can also see they try to isolate electrically and mechanically from the front using these coppers, so they allow, or they isolate electrically and vibration, all that kind of stuff. So that's quite good to make the shaft move good and nice, even if it's not super duper perfect straight. And of course also there is no direct electrical connection from the shaft and into the switch area. There's a wall here that is grounded and again shields everything here from outside environment. So here is the transformer, specially made for this unit. And yeah, caution high voltage. Obviously you will have a very high voltage from the transformer because you are comparing with a voltage and showing the difference on the meter. So of course this thing generates the same voltage as it's measuring. That's the whole point of this, how this unit works. So that is my mains on-off switch, and it is of course connected using a long shaft to the back where mains entry is, so we don't have mains going in and out of the unit. All the boards here, they just hang loosely like that, and they're connected using wires between them. We got a few pretty cool things going on the circuit boards, and I was hoping to be able to show you some of those details. So the first board right here is the null detector. So this one compares, of course, the input voltage with the reference resistors, and all the signals from the reference resistors, they come to this potentiometer over here, and this sets, of course, all the ranges. And since this unit was designed in 1967, right after all the tubes and all that, so you can imagine it's normal to have all the cool things in sockets. So all the transistors, they are neatly in sockets. How cool. A few of the sockets, they're not super beautiful or straight mounted, especially that one. They didn't clean the circuit board perfectly. I'm looking for leaked capacitors or anything that will prevent me from having a nice success. See these Teflon inserts? That's of course due to the very high impedance, and they don't want any kind of leakage from anything. Look at the way this input goes into that box. Yeah, we gotta open the box and have a look, right? This is just so beautiful. Look at that. Everything is mounted a little bit high and free to avoid capacitance and leakage and everything. Really, really nice. Yeah, I better close this back again since it's all nice and beautiful. I just rotated the instrument a little bit so we can play with the other boards over here. I took a nice bunch of close-up pictures so I can see all the different colors of all the wires. Where are they going, and into all the different connectors. I mean, see, here's an orange wire that goes just from this one to that one. And here is the dangerous one. Ooh, be careful not to touch that one. And here's the reference amplifier unit. All the resistors used for the different ranges, I think. Yeah, so in here we got super high precision wire wound resistors, and here we got Zener diodes, and that transistor here is a 2-in-1 for a balanced amplifier coupling. They really took it seriously. See, Zener diode info. So the part number and the, let's see if we can get this. The pack release date. 68. Oops. Ooh, I don't want to damage this board. It looks like this was repaired. You can see some solder job here. This transistor was replaced. And it also reveals by somebody's handwriting here. They put some numbers for some reason. And why did they put in some other numbers compared to the... I don't know what is going on. This is probably... Those are the color codes. Look at that. 6, 7, 8. 6, 7, 8. Oh, genius. So somebody was a lot smarter compared to the Fluke dudes who just gave them all sorts of random numbers that isn't really related to the color codes. That's the last of the 3 boards here. This one is called the A3 inverter. So I believe this one, see, there's a little push-pull oscillator right there, and we got some rectifiers and all that kind of stuff. And so we got a little transformer here with quite a lot of tappings to do all sorts of things. The big problem is there is no schematic available for exactly this model and type. So that makes it a little bit difficult. But what I think is happening when you change the different ranges, obviously the generator part of it will generate different voltages. So that makes a lot of sense. And then we got the different voltages. You adjust them here on the trimmers. It has to be something like that, right? I figured out one of the screws here of this transformer actually hits the transistor they replaced on the other board here. You can even see the scratch marks on the top of that transistor. I mean, that is a little bit stupid. If you just, why would you have it this high up? Yeah, I better fix that. And then I want to try and assemble everything. And then I think I would like to try and see if it works. This is going to be my very first power on. Let's first try with mains applied, and we don't see anything bad happens. And it's using 1.8. So that is fine, right? So here's what I've done. I'm now in 10 volt range. I put it for 10.000 and my input is 10.1. And since I am here now in 1 volt sensitivity, right? So this is why I see a little bit positive, because my input is positive compared to what I have here. So if I put this for 1, it should go to 0. So that is interesting. Let's try and dial the sensitivity. So it should not be that one, but it should be that one, right? And then I can dial it to 0. That is interesting, right? So what I think we have, let's just see if I'm right. 10.1034. You see, it's not the 5, but it's 3, 4. I think this is what we're reading right here. So what have we got in reality? Let's go over here. So I have 10.1022. So it is only 1.2 millivolts wrong. And I didn't even wait for warm-up. Okay, that's interesting. Let's leave everything like it is here and wait at least 1 hour, and then we're gonna see what happens. So I've been working with this fantastic unit the whole day, and it's actually still a little bit of fun. I wrote one of my buddies, Peter, and it turns out he also got one of these. Not exactly the same 891, but the 893 version. So it's a little bit different, but some of the circuit boards there are the same. And he happens to have the service manual. So what I learned from his service manual is the Zener reference board. Remember when I showed the Zener board here? There's a test point down here where you can measure the 17 volts reference, and this trimmer right there is the adjustment for the 17.00 volts reference. And exactly at that point, all the temperature things is fantastic. This is what we aim for first before we do any other calibrations. But it just happens to be the only thing that was wrong with my unit. So I want to show you something. The DC voltage I come with is 10.102, and this is verified by a calibrated instrument. As you can see here, we got 2 more digits, so it is definitely 10200. Let's just say that, okay? So we round it up a little bit, and then we fly all the way here. Let's have a look what we got here. 10.1020. And now it goes into 0. I am now in the finest range here, and now it's just, you have to more or less hold your breath while you're dialing this one. Look at that. See where I am? I think this is perfectly fine. I'm really happy about this unit now, I must say. So now it's accurate. And you need a very expensive modern meter to be able to beat this. And this one will beat it by a huge factor when it comes to input impedance. Because at this magic point where we have 0, then there's absolutely no current whatsoever going in or out of your instrument. And that is one fantastic feature of this instrument. This also means I could remove the DC voltage from my power supply, and then I can of course measure the voltage out of my Fluke voltmeter to be more or less the same voltage, because there's no current going. I think that is funny. Of course you can use it as a power supply. And now it's of course hammering out because I am in fact loading it a tiny little bit, because this one is of course loading the voltage a tiny bit by its voltage dividers. But this good old fantastic thing is not using voltage dividers to measure anything. It's a bridge, and that is the difference. Yeah, I am super happy about it, and it is fantastic technology. That is just how it is. So I think I will say thank you very much for watching. I hope you had a little bit of fun. Please like and subscribe and tell all your friends to come by. And I will maybe make a new video tomorrow.